All right, and we are continuing our lecture with this slide here. In five easy steps, find the sine of 11 pi over 6. All right, so first sketch this diagram here. Make sure you can see that your initial side is right along the x-axis there and that your terminal side has been rotated around to our fourth quadrant here. So as we start to find exact trig of angles, especially those past 90 degrees, we need to start drawing them in our coordinate plane in standard position. This is standard position once again, where the axis of rotation is right there at the origin, and we've been rotated from that initial side along the positive x-axis. All right, so what we want to do is we're going to assume that we have the diagram. If we don't have the diagram, then we're going to sketch the diagram. And then step one is we're going to place a point far out on the terminal side. All right, so this is my initial side, this is my terminal side. I'm going to put a point all the way out here at the end of that arrow and make a solid point on that line. All right, step two. It's called dropping a line, but sometimes you don't drop the line, sometimes you lift up the line with a balloon, but I'm just going to call it drop a line to the x-axis to make a triangle. All right, so we picked this point far out. We drop a line to the x-axis, but because we're below the x-axis, it's like it's being lifted up with a balloon. And now we've constructed a triangle here. All right, step three. All right, we want to fill in the interior angles of the triangle. Fill in the interior angles of the triangle. Well, if we went straight up to the x-axis, the most direct path there is going to construct a right triangle. So that's always going to be a right triangle right there, so we know 90 degrees. Now this exterior angle here gives us a clue to what the interior angle is. For one, we know that a full revolution is 360 degrees, and we know that we've rotated 11 pi over 6 radians. So let me convert that 11 pi over 6 radians into degrees by multiplying by 180 over pi. Pi's cancel out, and I can do, just in my calculator, 11 times 180 divided by 6, and I get that this is 330 degrees. Also, if you've got your unit circle, you could just look and see that 11 pi over 6 is 330, but know that you can always calculate it. So this is 330, and I'm sure we can do this part in our head. If the full revolution is 360, but we've only gotten 330, this interior angle here must be 30. And it looks kind of like a 30-degree angle. If we've got a pretty narrow angle, it's pretty much always 30 degrees, at least for the next couple of days. All right, and then triangle sum postulate. The interior angles of a triangle have to add up to 180, so this here has to be 60. So I've got a 30, 60, 90. All right, step 4. Label the sides with those of a special triangle. So a 30, 60, 90, I could label the sides 1, 2, and the square root of 3. Remember, hypotenuse is always the 2 because the square root of 3 is about 1.7. So this is 1, 1.7, and 2. All right. But there's kind of a caveat here that going down or left is negative. So this 1 over here, because it came down from the x-axis to get to that point, is a negative 1. Hypotenuse, always positive though. It's only the adjacent and the opposite that can be negative. If this triangle comes over here, that adjacent side length is going to be negative. And if we come down either over here or over here, that opposite side length is going to be negative. So let me even add that in. Hypotenuse, always positive. Okay. This is going to be more than 5 steps. Because in step 5, we're still not done. We need to label the sides again. But this time with the tags opposite, adjacent, and hypotenuse. So based off of an onlooker standing at the origin, which side would be the opposite, the adjacent, and the hypotenuse? We can always designate the 3 sides to be one of those 3. Well, our longest side is going to be the hypotenuse. This negative 1 over here is the opposite. And this square root of 3 right here is the adjacent. All right, and now step 6. So I have to change that. It's 6 easy steps. We're going to pick the right ratio from SOHCAHTOA and fill it in with actual numbers. All right, so pick the right ratio from SOHCAHTOA and fill it in with actual numbers. Well, we were asked to find the sine of this angle. So we want the SO part of SOHCAHTOA. So we want opposite over hypotenuse. Let's look at this. The opposite is negative 1. The hypotenuse is 2. So negative 1 over 2. And then simplify if need be. We don't want any radicals in our denominator. But here, negative 1 over 2, that is a fine answer. And we can double check by plugging in sine of 11 pi over 6 radians into our calculator. You will get negative 1/2. Okay, let me zoom that out real quick and just make sure I didn't miss anything. So place a point far out on the terminal side, drop a line to the y-axis to make a triangle, fill in the interior angles of that triangle, label the sides with those of a special triangle. If you go left or down, it's a negative. Label the sides again with the tags opposite, adjacent, hypotenuse. Pick the right ratio from SOHCAHTOA and fill it in with actual numbers. All right. A good way to double check the sign of our final answer is to use this all students take calc diagram. So all students take calc. This tells us which trig functions are positive in each quadrant. Here we're in that 4th quadrant. Cosine is positive, meaning sine should be negative, and we did get a negative answer. All right, so let's find the cosine of negative 225 degrees using that system we just talked about. So I need to draw a right triangle in standard position with a negative 225 degree angle. So let's start with a couple axes. I got to draw negative 225. So my initial side is right along here. I'm going to rotate it negative 225. So let's see, I go negative 90. I'm going down first because it's a negative. Negative 180. And then I've got 45 more, so I go right to here to get to negative 225. And this is my terminal side. Here, that's my negative 225 degree angle. Lands me in the second quadrant over here with my terminal side. All right, gonna put a point far out on that terminal side and then drop an anchor straight down to the x-axis, thus constructing my right triangle. All right, so I dropped my anchor down to the x-axis, constructed a right triangle. Let's fill in the interior angles. Let's see. This was negative 180, and then we went 45 more. I'm just going to treat this like a positive 45 now. Now, when we go to fill in the interior angles, now we don't care about negatives anymore. This is a 45, 45, 90. 45, 45, 90. Well, I remember my 45, 45, 90. Let me just sketch a real tiny one was 1, 1 and the square root of 2. So this length here has to be 1, this length here has to be 1, this length here is the square root of 2. Now, check and see if any of these are negative. Well, the bottom here, I went to the left of my origin, so this is a negative 1 right here. The opposite, though, is positive. The hypotenuse is always positive. This one's coming up. Hypotenuse is measured from the origin out, so it's always positive. Okay, let's label them again with opposite, adjacent, and hypotenuse. This 1 over here is the opposite. This negative 1 down here is the adjacent relative to the origin. And then this side length over here is the hypotenuse. Now, which part of SOHCAHTOA do I want? I want the ka of SOHCAHTOA, adjacent over hypotenuse. So my adjacent is negative 1. My hypotenuse is the square root of 2. This isn't simplified because I've got a radical on the bottom, so I want to take 1 over the square root of 2 and multiply it by root 2 over root 2 to get negative root 2 over 2 is my final answer. All right, let's double check with our all students take calc diagram. Sine should be positive, therefore cosine and tangent are negative. So cosine did give me a negative for this quadrant. And now let's just try this in our calculator. I want to check them in degree mode. Cosine of negative 225. I get that number there. Let's see if negative root 2 divided by 2 gets me the same number, and it sure does. Okay, on to our next one. This one doesn't give me the angle, it just gives me a point on the terminal side. This one actually ends up being easier. So let's still, from that point, drop a line down or raise a balloon up to the x-axis, and now let's label our sides. Well, if this point is at 6, negative 8, that means that this length here must be 6, this length here must be negative 8. All right, and now I just need to find the sine of this angle here. This is theta. That means I need to know the hypotenuse because sine is opposite over hypotenuse. So I need to do the Pythagorean theorem, a squared plus b squared equals c squared, to find this length c here. Here I don't care that this is negative because when it gets squared it's going to become positive anyway. So 6 squared plus, I'll plug it in as negative. Negative 8 squared equals c squared. 36 plus 64 equals c squared. 100 equals c squared. Square root. 10 equals c. So this length here is 10. Now I'm going to label from that. This is my opposite. This is my adjacent. This is my hypotenuse. I want opposite over hypotenuse. So negative 8 over 10 simplifies to be negative 4 over 5. Okay. Here's some formulas. I would pause this and write these all down, but I don't recommend trying to memorize these. But this is a way to go from those ordered pairs out on our unit circle directly to the trig values of the angles that whose terminal side intersect with that ordered pair. But I always just think about it using my those 6 simple steps we talked about earlier. But these are still, they can be helpful. I just don't recommend memorizing them. Okay, we'll try this one with the formula, cosine of 60 degrees. So what we would want to do is get out your unit circle diagrams, right? And we would look at the 60-degree angle, the ordered pair out here. Let's see if I can remember it. I think it's 0.5, comma, let's see, square root of 3/2. I think we just left it as a fraction. It was like 1/2, comma, square root of 3/2. All right, well, the cosine is supposed to be the x value of that ordered pair. So we just look at this x value here, and we say cosine of 60 degrees equals 1/2. Let me see if that's actually right, because that will tell me if I remembered my unit circle correctly. Cosine of 60 is 1/2, yeah. So if you've got the whole unit circle, yeah, you can find your cosine and sine and tangent values really quick. It's just, then you just always have to carry a unit circle with you, which nobody wants to do that. Here's a cool diagram that shows the relationship between cosine, sine, and tangent. Also, it kind of shows why tangent is called tangent, because the line is tangent to this curve. It's our unit circle, so the radius is 1. Yeah, worth copying down. It's not how I've memorized it, but I think this is a good diagram to just have in your notes. So pause it, copy down this diagram. And yeah, that's the end of this video. Have a great rest of your day. Good luck with the worksheet.